Right. Ready? So good morning all of you.
Good morning, sir.
The summary of the last lecture, we have discussed this band theory of solids. What is our conclusion there? In case of a free electron, we have energy versus K, that is proportional to K square. That's just like a parabola. So means what happened, as K value is increasing, the E value is also keep on increasing. Just like a parabola means it is going to infinite. But that is the behavior of the free electron. But later what we concluded, this is not the right way, because the electron is moving in the periodic potential of the lattice. Then we got the energy versus K graph, something else, okay, which is having concave at the bottom and convex at the top. That means the curvatures at the top and the bottom are opposite. This is what we have seen in yesterday's class. Am I right? Now, ready? So please take the heading, very important, very important. So characteristics or properties of electron, moving in a periodic potential, This is very important, very crucial. Listen carefully. Definitely there is a question from this part. That means here we are going to discuss velocity of the electron, effective mass of the electron, and F. What is F? A ratio of free mass and effective mass. Okay. Are you ready? Right. Boys, are you ready?
Yes, sir.
Right. So here first I am taking as usual a free electron. I am taking the free electron. Before going to talk about that electron which is moving in the periodic potential, let us take free electron. What is the energy of a free electron? H cross square K square by 2a. I would like to find now velocity. I am talking about the first one is velocity. First property. Okay. So everybody know velocity means a group velocity. Group velocity is equal to. So now I am going to multiply with the H cross and H cross here. That's why 1 by H cross d H cross omega by dk. I hope you remember. This is nothing but Vg equal to 1 by H cross dE by dk. This is the velocity of the electron. If you see your previous papers, they will give the dispersion relation E. What they will ask is velocity of the electron. They won't say group velocity. What they will say? Velocity of the electron. Velocity of the electron equal to 1
by H cross dE by dk.
Especially they will ask at zone boundaries. At zone boundaries means which zones are? Always first brilliant zone. If you didn't mention anything, always we have to take the first brilliant zone. Otherwise, especially he will mention second, third, something like that. Good. So this is the group velocity, or simply a velocity of electron. That's good. Very important, Amma. Don't neglect. Okay. So here I have already taken the free electron. That's why velocity of the electron. Which electron it is? Free electron. Okay. This is a 1 by H cross. Differentiation of E with respect to K. Come on. H cross square 2K by 2m. 2 gets cancelled. Finally, H cross also cancel. H cross into K. This is constant, this is constant. That's why I can take velocity of the free electron is simply some constant into K. Is it proportional to K or not? What is the meaning of that? As a K is increasing, if K increasing, so finally, what is the behavior of a free electron? In the quantum mechanics also we have explained. The range of the energy spectrum of the free electron is 0 to infinity. Continuous spectrum. If you see the quantum mechanics classes, first we have explained free particle and a bound particle. There we have written the spectrum is continuous. Means what? It is having all the values from 0 to infinity. That's the meaning. Okay. So now let us see. This is the energy versus K of a free particle. What it is? Is it a parabola? So this is a proportional to K square. Now I am taking velocity of the electron, that is a free electron. This is the K value. Now come on, say velocity is a proportional to K. What it is? Straight line. It's a keep on increasing. Where it is going? Infinite. So what does it mean? For a free electron, very important. For a free electron, as a K increases, velocity is also increases. That means K increases, energy increases, hence velocity of the electron is also increased. This is the behavior of a free electron. Okay, cool. Now come to this. Ready? Now I'm taking the second case. What is that? That is a nearly free electron. I hope you know what is the meaning of this. We have assumed in the vicinity of the nucleus it is a free, and outside the nucleus it is a bound. Nearly a free electron. That is a band theory of solids. So are you ready? So nearly free electron theory I have taken, that is a band theory of solids, and let us see what happened. In the last class already we got energy versus K. Carefully listen please. And we got this kind of spectrum. Okay, that means at the bottom we have a concave shape and at the top we have convex shape. That means the top and the bottom are having opposite curvatures. That's good. So everybody know at this, I mean this is the E versus K, that's why at this point slope. So could you please tell me what is the slope? dE by dK equal to, now at this top and this is bottom. At this top also, could you please tell me? And one more, is it a minima or a maxima? Minima. This one? Maxima. I hope you know, you remember, at a minima what will happen? At a minima what will happen? d square E by dk square is, very few people are responding, maybe you are not interested. At a maxima, second derivative, d square E by dk square is negative. This is what we have discussed in the maxima minima of mathematics. And in somewhere, definitely there exists a point between. If you remember, while we are explaining the mathematics, we explain like this. I don't know how many of you remember. The curvatures are opposite like this. Then we have taken the tangents. Then we got like this. So this is acute and this is obtuse, maxima, minima. In between we have point of inflection. Okay. So somewhere in the middle, I don't know where it is, somewhere in the middle, we have point of inflection. So what is the meaning of a point of inflection? Come on, say. Okay. Now I want to take this something. Shall I take like this? d by dk into dE by dk equal to what? 0. You tell me one thing. d by dk into dE by dk equal to 0. Then what about this? Okay, constant. But what is that constant? Differentiation of some function is 0. What is that function? Constant. That constant is what? Maxima or minima? What is that? Array, differentiation of a function is 0. What is the function? Maximum. That maximum only you are saying a constant. That minimum only you are saying a constant. ఇక బ్రెయిన్స్ అక్కడే ఉంటాయి, ఇక్కడ రావు అనమాట. చావండి. dE by dk is what? Constant. But what is that constant value? Maxima or minima. Either maxima or minima. The first derivative of a function is 0 when it is possible if the function is having maxima or minima. Here we have explained now. First derivative is 0. That means differentiation of something is 0. That something is what? Either maxima or minima. Not only constant. Constant, I accept. What is that constant value? Maximum possible value is that constant. Okay, leave it. So maybe you are not understanding. That's it. This is the about this curvature. Now ready. Once again I am taking that graph. Whatever we have taken, this is the energy versus K. Observe carefully. This is the energy versus K. So here we have something like this. Something like this. Am I right? Already we have done this. And somewhere here we have zone boundary. Say yes or no? This is what? This is what? Good. Just now we have seen this side we are having a point somewhere in the middle point of inflection. I am taking somewhere, I don't know where it is, just I am taking a K naught. This is what? Minus K naught. Now this is the energy versus K of a particle, of an electron moving in the periodic potential. Now for this we are going to draw the velocity. Carefully observe. Right. So now these yellow lines represent the zone boundaries and these white lines represent the point of inflection. Are you interested? Otherwise we will stop. Ready? So at this point, everyone, already we have defined the formula. V equal to, already we have defined the formula. V equal to 1 by h cross dE by dk. dE by dk is nothing but the slope of this energy versus k. Say yes or no? Right. So wherever slope is 0, there the velocity is 0. Say yes or no? Now at the top slope, that's why velocity. Next, at the bottom slope, that's why. Next, 0. At the top, bottom and the top. Clear? But this is the negative k and that is a positive k. And at a point of inflection, you are saying it's a constant. Okay, what is that constant? Maybe maxima, maybe minimum. Minimum value means you can take a negative value. Maximum value you can take a positive. Understand? If a k is a positive, velocity is a positive. If k is a negative, velocity is a negative. That's good. Now, at the point of inflection, your velocity should be maximum or minimum? Similarly, at a point of inflection, your velocity is minimum but negative value. Minimum means there, what is that? Negative. That's it. Minimum and maximum in the negative direction. What is that? Maximum in the negative. You should not say minimum, okay? Maximum in the negative direction. That's good. So this is the velocity of the electron in the lattice. What did you observe? Please observe both. This is the free electron and this is the electron in the lattice. In this case, as k is increasing, velocity is keep on increasing. Means as energy increases, velocity is also increases. Common sense. Now come to this. Please observe energy and velocity. Energy and velocity. From here to here, your energy is increasing or decreasing? From here to here also your energy is what? Actually energy is keep on increasing only. Okay, right. Once again, this point origin to point of inflection, your energy, your velocity, wait, beyond point of inflection your energy, but velocity decreases. That's it. This is the different behavior than the free electron. Common sense, free electron, as energy increases, velocity also must be increased. But the electron is moving in the periodic potential. That's why what happened in the beginning, as energy is increasing, velocity increasing up to point of inflection, it reaches a maximum value, and beyond that point of inflection, although energy is increases, velocity decreases. You have to say this in the interviews. If they ask what kind of behavior you will observe if you treat the electron is not completely free, then what you have to say? First one, velocity property. In case of a free electron, velocity increases as energy increases. In case of a not free electron theory or nearly free electron theory, initially velocity increases as energy increases and reaches a maximum value at point of inflection. After that, although energy increases, velocity decreases. Everybody understand? Come on. If you write in your own words, that is better. This is the different behavior. Very important. Understand and do it. Understand and do it. Why you are drawing the graphs like that? I cannot take minimum value. The reason is what? Here in the both the cases energy is increasing. As energy is increasing, velocity is also maximum. So that's why I cannot say minimum. Only I have to take what? Maximum. Minimum we can't take. This is not the minimum. Maximum in the negative direction. That's it. Because it's a vector quantity. Velocity of the electron is 0 at top and bottom of energy versus k graph, k curve. Next, velocity of electron is maximum at point of inflection. Next, that means beyond point of inflection, So although energy increases, velocity of electron is decreases. Although energy of the electron increases, but velocity of the electron decreases. That is the different behavior. Here I have shown, in this region velocity increases, but in this region velocity decreases, although energy is increasing. Ready? So velocity of the electron is 0 at the top and bottom of this energy versus k graph, okay, and velocity of the electron is a maximum at the point of inflection, and beyond the point of inflection, although your energy is increasing, but the velocity is decreasing. Please write properly. Right, this is the first discussion, velocity. You will get a question, Babu, find the velocity of the electron, and they will give the dispersion relation energy, and you have to find the velocity. That is, what is the velocity formula? 1 by h cross dE by dk. If you forget, velocity is always the group velocity, d omega by dk. Just convert omega into E, that is E by h cross. Next, second one. Ready? Yeah. Please write that properly. Beyond the point of inflection, although energy is increasing, the velocity of the electron decreases. This is the different behavior than that of free electron. just to understand what's happening there. But the application is finding the velocity. Ready, Amma? Calculate ready? Anyone is writing? Right. This is very important. Effective mass of the electron. First of all, why you are considering the effective mass? Let us discuss. Wait a minute. After that, we will see. We will derive. Actually, here, according to band theory of solids, we have considered electron is not completely free. Electron is not completely free. Yes. So what? If the electron is not completely free, till now whatever you have done, the free electron theory, whatever it is a wave nature or a particle nature, according to de Broglie, you know the electron is having both a wave as well as a particle. So if you are not treating it as a free electron, definitely its wave and particle nature will be changed due to the motion of the electron in the periodic potential. Wait. So this is the assumption we made. That's why wave particle nature of electron is different from that of free electron. Okay, cool. Now let us start the derivation. So what nature we will get, what different nature we will get, let us see. Now here I am considering this is the lattice. Listen carefully. And the lattice we have the plus ZE core ions. That means what? Every positive charged particle produce electric field. Say yes or no? So I am assuming the electric field of this lattice is some E like this. Sir, why you are not taking capital E? Already taken there. Again I will use that expression. That's why I am not using E, just I am using some symbol. So don't worry, this is what? Electric field. Good. And in this, here we have electron. Electron is moving in this electric field of lattice. Cool. Let us suppose it's a velocity of the electron. I am taking one dimension, Babu. Everything we will do for one dimension. So velocity equal to how much, Babu? That implies I can write dx equal to cool. Up to this, any doubt? Just we have taken the lattice. If you have problem, I will write this also. Something like this. I hope everybody know what is the amount of work done. I am assuming it travels a distance dx. Then what is the amount of work done? dw equal to f into dx. I am not taking any f bar or something like that, simply taking the magnitudes only. F dx. What is this F ma? Force acting on the electron. What is that? E, electric field. E. Okay. So that's it. This is nothing but E dx. This is the amount of work done. Finally, again I am taking very simple, amma, don't get tension. This is E, of course, electric field. What is a dx? V. That's good. So I hope you know the amount of work done by what? By the field. Say yes or no? By the field. On. Charged and electron. This will be stored in the form of energy. Say yes or no? Stored in the form of energy. That's good. That story is over. So that's why I can take that dw is nothing but what? E for not electric field, energy equal to, come on, E electric field V dt. Few minutes back we have already defined the velocity of the electron. Could you please tell me what is the velocity of the electron? E is not electric field, energy. So, oh, dE by dk. Now, E, electric field 1 by h cross dE by dk into cool. Now, I am bringing this dt this side. If you want, you can bring, otherwise no issue. dE by dt. Come on. Now I can cancel this dE because all these are constants. So then finally I can bring this dk this side. So what I get here, dk by dt equal to E up to this. Any trouble? Say yes or no? No, I am not getting any voice. Are you understanding? Yes. Right. Now this is important. Okay. So what you are talking about? So your electron is moving under a force. That's why it is not a free particle. A free particle means what? No force, no interaction. Whenever it is free, its mass is what? M. Now here your electron is moving under some force. Which force? Some electric force. Because your lattice contains the positive ions, it is giving the electric field. In that electric field your charged particle is moving. Then again I want to find the mass. Then mass is nothing but what? Force by acceleration. Say yes or no? That's why I would like to find acceleration. The acceleration A equal to how much? F by m. Yeah, acceleration is F by m. Okay, so 1 minute. Yeah, acceleration. Shall I write it as dV by dt? Then it's again d by dt. What is the velocity? E by dk. Are you observing? Now acceleration equal to, I am writing that 1 by h cross outside, 1 by h cross. This is a dE by dk. Your energy is varying with respect to k, not with respect to t. So that's why how to change this differentiation? d by dk, understand, into, very few people are saying, d by dk into chain rule, d by dk into dE by dk into dk by dt. I hope everybody understand what is this. A equal to 1 by h cross, this is nothing but d square E by dk square into dk by dt already there. Charge, electric field and h cross. Finally, ready? I think again I can write E is nothing but charge into electric field is nothing but a force. If you want you can write that also. Acceleration equal to 1 by h cross 1 by h cross 1 by h cross square d square E by dk square into force. Now I told you I want the mass of the electron, that's why F by A. F by A. Could you please tell me what is F by A? 1 by 1 by h cross square. So that is nothing but what again? H cross square by d square E by dk square. And the force by acceleration is nothing but a mass, but that free electron mass and this value never be equal. That's why whatever the value you are getting, that is not equal to mass of a free electron. That's why we are representing as m star, where m star is the effective mass of the electron. What is this effective mass of the electron? Because it is moving under the force field, So that's why here that mass is affected means mass changes. So how much it changes? M star equal to H cross square by D square E by dk square. And definitely it is not equal to M. This is the M star of E. What is the effective mass of hole? Same. But sign difference. Same magnitude, same amount, but a sign will be there for the holes. Of course, we are not talking about any holes. Just remember, if anybody asks, mass of electron and effective mass of electron and effective mass of holes both are same. Come on, write down. So finally we got, I am writing here the conclusion, there is no space, that is why I am writing here. Effective mass of the electron, M star equal to, don't forget, H cross square by D square E by dk square. Very, 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 very important, Amma, please. And I told you why we are studying the band theory of solids. We don't know the behavior of conductors. That means how the solids are behaving like a conductor and how one solid is behaving like an insulator. We don't know that. So that's why we are discussing this theory. Our final aim is to show that what is the condition of a solid or for a solid to behave like a conductor. Anybody knows? Okay. Shall I tell you one thing? Where is the problem? Whatever you have studied in MSc, again we are studying, but the problem is in MSc you people are not studying. Or maybe you studied, you don't know that is this one, maybe. Something is happening. Really, if you studied properly in MSc, these things won't take much time. 3 months we can finish the coaching. Maybe your syllabus is not equivalent to CSIR or something is happening. Okay, university ఉంటుంది నాగార్జున యూనివర్సిటీ అని అప్ టు 2010 11 there is no EM theory paper for MSc physics students. Why? No one is ready to teach there. That's why they remove the paper. And after that these students complained and finally they kept the paper. That's why you please become professors, lecturers, then only students will get something, otherwise no. What you are thinking is, let us get a job and we will buy a house and we will get married and we will be happy. Yes, happy for only 3 or 4 lives, but not for many lives. Become a lecturer, become a professor. As a MSc physics student, that is your aim actually. I mean research or lecturer, anything. If you didn't get anything, just stay at home and start tuitions for +2 or BSc. So the second property is over. Effective mass m star. This is given, I think around seven times this question was there in CSIR. What they will give? Dispersion relation. What you have to find? Effective mass of the electron. Only single formula. M star equal to h cross square by d square e by dk square. In one exam, they asked what is the effective mass tensor. No need to get tension. Tensor means 9 components will be there. There you are taking a d square e by dk square. Tensor, first row, first column, kx square. Next one, kx, dkx, dky. I hope you are understanding what I am saying. X, y, z. So, second, diagonal elements, d square e by dkx square, d square e by dky square, d square e by dkz square. Cross elements, combination of x, y, y, z, zx like that. That's it. Only one time they have given that for 5 marks, tensor. Oh. Effective mass of electron. What is the answer you got? H cross square by d square e by dk square. Don't forget, Amma, very important, very important. Ready? Yeah? Over. Stop. Now this is what we have derived till now. Effective mass of the electron. Sir, why this mass change came? Because electron is not free and it is moving in the force influenced field which is given by the positive ion course of the ion. Positive ion course. Ready? Of the lattice. Right. Now here we are going to define one more quantity. Very important. I would like to take the ratio. I am defining that ratio as F for fraction, that's it. It's a fraction of electrons. Right, F for fraction, which is the ratio of m and m star. That means m by m star. This is the ratio of mass of free electron to the effective mass of the effective mass of electron in lattice. Ready? So F equal to m by m star, then here you are getting, ready, m by m star by h cross square d square E by dk square. So this is F. Sir, what is this F? This indicates the fraction of electrons available for the conduction process. If this fraction is 0, there are no electrons available for the conduction, then it behaves like a insulator. If a maximum number of electrons available for the conduction, conduct. That's it. Wait a minute. Very important. What is this F? Fraction of electrons available for the conduction process. Good. Wait a minute. I'm going to find this. Everyone please listen. Sir, okay, it's a fraction, but how can I find the total number of electrons? Yes, you can find. This is the total number of electrons available. Listen please. Is simply equal to sigma F. What is that? Sigma F. I will tell you, wait a minute. Sigma F, but it is not a few or not a discrete or not a countable. It's uncountable states will be there. That's why integral F, this fraction, into density of states. So this will give you the total number of electrons. This F gives the fraction of electrons available. Now you want the total number. That means you have to multiply with what? Density of states. And again you have to integrate. Is it clear? And now the density of states in one dimension. Density of states in one dimension. How you will find? First you will write n. What is n for one dimension? One dimension. So first we will write n equal to L by 2 pi into k. Okay. So then dn equal to, or you can write a small n also, it's okay, no problem. I am writing dn. Dn equal to L by 2 pi into, but unfortunately you have to multiply with the degeneracy. Because it's electron system. You are filling the electrons. There exists a spin degeneracy. That's why this 2 is what? Are you listening? Ma, please listen. That's good. And finally, here I am considering a particular energy band, nothing but a valency band. Now I am considering conduction band. Valency band, from there electrons will go to the conduction band. Listen. All of you please listen. So I have considered a particular energy band. Actually this is where the valence electrons present. That's why we can take it as a valence band. Now I am assuming the electrons are filled in the levels up to a certain k value. I don't know what is that. Just I am assuming it as a k1. It may be something else. I don't know what it is. And this is what? Minus k1. Are you observing? Now here we have one electron up, down, something like that. That's why we have taken here 2. Everybody understand? Now, ready amma? I have taken a valency band of a particular atom. Okay. So that means that solid is made up of those atoms, and this is the valence band. Valence band means what? It may or may not be completely filled. We don't know. So that's why I am assuming the energy levels are filled up to a particular K value. How much it is? K1. Let us suppose. Now I am going to find the number of electrons available for conduction. Everyone, available for conduction. Are you ready? So integral, this is F. F is nothing but m by h cross square d square E by dk square into density of states L by pi, 2 gets cancelled, into now m outside, L outside, pi h cross square outside, integral, come on, d square E by dk square into dk. I told you, you have taken the k value from where to where? That means you have considered the energy levels are completely filled up to a particular k value. Is that clear? Right. That means from where to where? This is the even function. Okay? Sure? Okay. So, let us say odd function. Let us say odd function. First derivative, what you will get? Sine odd or even? Take first derivative. Even. Again first derivative. Minus you are getting. Okay. So then now what is d square E by dk square? What is E? You are taking a free electron, nearly free electron. Free electron function is even. What is that? H cross square k square by. Make inka confusion ga unte listen. You have drawn this graph for energy versus k. K positive, energy positive. K negative, energy positive. Me bonda negative gaadu positive. K positive, energy positive, K negative, energy positive. Means what? Energy is symmetric, even. Clear? So my energy function is even function. That's why I can write this as I can write this as 2m L by, listen, don't write, pi h cross square, 0 to K1. That is the maximum possible level up to which your energy levels are filled in valence band. How much? Differentiation and integration. How much? dE by. Shall I write directly? వద్దులే మీకు ఏం అర్థమవుతుందో 0 to k1 d square E by dk square into k. Differentiation integration. One time cancel na. Then the number of electrons available equal to, come on, 2ml by h cross square pi dE by dk, because one time integration differentiation gets and limits from where to where? So 0 to k1. Is it okay? Upper limit. That means it's simply 2ml by pi h cross square dE by dk, where you will substitute at k equal to how much? Okay, that's it. And upper limit, lower limit leave it 0. So this is the number of electrons we got, the total number of electrons available, for the conduction process, whenever the valence band is filled up to a particular k value. What is that? K1. Are you ready now? Come on. Number of free electrons available effective or fraction, that everything is over already discussed, no need to explain again and again. 2 ml by pi h cross square dE by dk at K1. Now carefully remember this. So what is the effective number of electrons participating up to a k level, up to a particular k level? What is the maximum number of possible electrons available in the conduction process? 2 ml by pi h cross square, slope dE by dk. Where? At a particular k, wherever you are considering. You will assume na, my electrons are filled up to 2p level, 3p level. We don't know where is your valence electron. Your valence electron will be where? 3d, 3p, something like that. For that electron there exists a particular k value. Ready. Okay, so these are the total number of electrons available for the conduction. So here we have already informed, our aim is to discuss how some solids are behaving like a conductors and how some solids are behaving like a insulator or semiconductors, what it is. Could you please tell me what is meant by conductor? What is meant by conductor? Okay, what is the difference between conductor and insulator? Conductor is having what? Free electron. Insulator? Not that much number of free electrons available that you are saying, or maybe nearly equal to 0. Oh. For example, this is a metal. This behaves like a conductor. Why it behaves like a conductor? The metal is having maximum number of free electron. Say yes or no? Okay. On that condition, let us apply. Ready? So for conductor, everyone. So when do you say that it is a conductor? If there exists maximum number of free electron. Wait. Ma listen please. Maximum number of free electrons. So here we have already formula is there. N equal to free electron formula 2 ml by pi h cross square dE by dk. Wait. This N must be 2 ml pi h cross, everything is a constant. The thing is, you should get dE by dk is a maximum. Please go back to the earlier velocity curve or something like that. We have explained before velocity curve, we have explained the energy spectrum E versus K. In the middle, we have written one point called point of inflection. Somewhere, point of, at that point of inflection, what you have written, please check. D square E by dk square is 0. And we have written d by dk of dE by dk, and I asked, you said a constant. But exactly what it is? Maximum. Constant, but what is that constant means? Maximum. So, slope is maximum at point of inflection. So, this also must be, because n is maximum means this is a constant, only dE by dk must be. This is a maximum only at point of inflection. So in conductor, your energy levels are filled up to point of inflection. If you consider the energy band, that is a valence band. Valency band of this conductor. Okay, are you ready? So according to this, the energy levels are filled only up to now tell me, your valency band is completely filled or incompletely filled? Your valency band is completely filled or incompletely filled? It is only filled up to what? Above point of inflection, all the states are waste. You are not interested, what we will do? Beyond point of inflection. Beyond point of inflection. గుర్రాన్ని నీటి దాకా తీసుకెళ్ళంగానే తాగించలేం కదా, మీరు కూడా అంతే. ఇంట్రెస్ట్ లేకుండా కూర్చొని చేస్తారు ఎందుకు? బియాండ్ పాయింట్ ఆఫ్ ఇన్ఫ్లెక్షన్ ద స్టేట్స్ ఆర్, ద ఎనర్జీ స్టేట్స్ ఆర్ ఎంటీ. బ్యూటిఫుల్ కాన్సెప్ట్ కూడా ఇన్ సవర్, అదే మీ కర్మ. దట్స్ ఇట్. సో దీస్ స్టేట్స్ ఆర్ empty. That means here only we have the electrons. Just example, how many I don't know, just. Oh, that means in case of conductor, if this material behaves like a conductor, means in this valence band, electron configuration will be there na, there exists a valence band na, that valency band is incompletely filled. That's it. The valence band is not completely filled. Not completely filled. Then it behaves like conductor. Now still not understanding. Come to this. Insulator. Ready. Okay. So what will happen in the insulator? Now the contrast I will take, reverse I will take, maybe at least you will understand here. And again I am taking this energy band, that is the valence band. Ready? Now I am taking this valence band, I am taking up to zone boundary, up to, okay na? Zone boundary means what? Peak, maximum. So all the states are completely filled. When what happened? Now go to the formula. N free electrons equal to 2 ml by pi h cross square dE by dk. Now dE by dk at which point? Zone boundary. Zone boundary means what? Maximum. Am I right or wrong? This is the maxima. At this maxima, could you please tell me dE by dk equal to? So maxima or zone boundary or something like this in terms of reciprocal lattice. So this will be what? That's why N is equal to number of free electrons. Zero. So why this is behaving like a insulator? Whatever the material you are preparing, that material is having completely filled valency band. That's why there is no process of excitation or something like that, because it is already completely filled. It won't participate in any conduction process. If it is incompletely filled, then what will happen? If you give small energy, either lattice vibration or something else, what it will do? It will participate in the conduction process, because there is a higher states na. The electron can go to higher states na. Here any higher states are there? In that band, any higher states, that's why there won't be any conduction or something like that. So finally, here the number of free electrons available, 0. So if valence band is completely filled, that behaves like insulator. That's it. Come on. Only up to this point of inflection is filled. Beyond that, empty. That's it. So we got all these properties of the electron which is moving in the periodic potential of the lattice. One is the first one is the velocity, next effective mass m star, next fraction F equal to m by m star. All these things we have discussed, and finally we have discussed a small thing, that is what makes a conductor behave, what makes a solid behave like a conductor, because once you consider the valency band of that material, that is not completely filled. That's why the electrons are available for the conduction process. But in case if the band is completely filled, so the no free electrons are available because already bounded, and this is completely filled. There is no process of excitation or something like that in this energy band. Ready? So finally, let me take the final graph. Now this is the energy, and here we have k-axis, and here we have point of inflection. First let me take the energy versus k. I hope you remember energy versus k. Is it okay? Now this is the peak, of course. Right, and somewhere here we have point of inflection. This is the point of inflection, red color line, please observe. And somewhere here we have same point of inflection. Right. Now this is the energy versus K. This is the energy versus K diagram. Energy versus K of what? Of an electron moving in the periodic potential. And then the next we got the velocity formula. Velocity equal to how much? 1 by h cross dE by dk. Now I am going to represent this velocity graph. This is the k-axis, and here it is a 0. Here it is a 0, here it is a 0, and here also a 0, but here it is a maximum. I hope you understand. Next, next we have got m star, that is the effective mass. Could you please tell me what is the effective mass? H cross square by d square E by 1 minute. Carefully please listen. Now this is the k-axis as usual. Now this is the velocity graph, and here we are going to draw the graph of m star versus k. Carefully observe please. Ready? Now this is the bottom of the curve, bottom of the E versus k. So here we have minima or maxima? Minima. Here? Maxima. If it is a minima, d square E by dk square is a positive or negative? Positive. Maxima d square E by dk square is a negative or positive? Negative. Say yes or no? And one more. Ready? At the point of inflection, d square E by dk square is how much? So m star graph, okay, is a becoming infinity at point of inflection, and lower part d square E by dk square is a positive, upper portion d square E by dk square is a negative. Understand? That's why. Are you ready? So, at a point of inflection it is going to infinity, but positive m star. Say yes or no? That's why this is the lower portion. What is this? Lower portion, lower part. Are you understanding? This one. This lower part is this one. Why it is like this? Common sense. At point of inflection, infinity. At point of inflection, infinity. Clear? Right. Ready. Next one. And upper portion d square E by dk square. But still, at a point of inflection, infinity. That's why, I hope you are observing. Negative, but infinity. Negative, but infinity. Is it clear? This is the positive now. This is what? Negative. Understand? So, this is the graph of m star. So, lower portion, and this represent what? Upper portion, upper part. The last one more is remaining. What is that? F. F equal to what? M by m star. Could you please tell me what is m by m star? M by h cross square d square E by dk square. Oh. So, at point of inflection f become 0. Already we have seen. Okay, at point of inflection f become 0. F becomes 0. Ready? Now I have taken this k. Ready? So here 0. Here. Next. This is what? D square E by dt, lower part d square E by d positive. Positive or negative? Okay, next. Upper part. That's it. So finally, these are the graphs of energy versus k, velocity versus k, m star versus k, and f versus k. Come on, make it fast. We'll do some problems. And tomorrow we have to start superconductivity. Please read the book. This part is very crucial for CSIR. Every year one question is there based on this effective mass, velocity, fraction F. So very, very, very crucial. Maximum questions came from M star and velocity. Today we need to start the digital electronics, otherwise it's difficult. Right. Start the problem. E of k equal to ak square plus bk power 4. Just find m star at k equal to k naught. So please write the formula of m star. M star equal to h cross square by d square e by dk square. Just find the 2 times derivative. First find 1 time. Aram se do it 1 by 1. After that 2 times derivative and put k equal to k naught. Please do the problem. No, Ashwati, please contact them. Actually, there is very poor, internet speed is not good. I think your that input camera is also very low quality coming. So please inform them and better to increase that speed. Why there is no Geo fiber net? Shruti, please ask whether Geo fiber net is there in your place, in your area. No. Please check. Luckily we got Bhubaneswar, that Geo fiber net. It's there. Right. So dE by dk is 2ak plus 4bkq. And again one more time derivative, 2a plus 12bk square. That means this is k naught square. I hope everybody got m star. Over. What is the answer? H cross square by 2a plus 12b k naught square. Next, come on. Wait. Energy relation is given. Of course, some extra A is given. Not an issue. What he is asking? M star at bottom of the band. Bottom of the band means what? Find and put k equal to 0. M star H cross square by d square E by, very easy, very easy. But at the bottom of the band, that means k equal to 0. Find the 2 times derivative and put k equal to 0. I think similar answer into, not into, a square a power 4. So second term is 0. I think you got the answer 2a square. Ade H cross square by 2a square. Next, third one, CSIR. Near the bottom of the band, always you have to take k equal to 0. This is the December 2013. Am I calculate ready? The energy of an electron, in a band is given by E of k equal to E naught minus b of cos kxa plus cos kya plus cos kza. Full stop. The effective mass at the bottom of the band, come on, do it. First do the 2 times derivative. Hello, 1 minute. Bottom of the band means k tends to 1 minute, not exactly k equal to 0, just take k tends to 0 approximation. Then cos ka is nearly equal to 1 minus k square a square by 2. That's why cos kxa 1 minus kx square a square by 2, 1 minus ky square a square by 2. Okay, please. Actually, he is not given yet. He said near the bottom of the band. In the question he mentioned near. Please take the approximation first. E of k equal to E naught minus b into 1 plus 1 plus 1, 3 minus kx square, ky square, kz square is nothing but what? K square a square by 2. Babu, kx square a square by 2, ky square a square by 2, kz square a square by 2. Take common a square by 2. Then kx square plus ky square plus kz square is k square. Now go for 2 times derivative. 1 time derivative and after that 2 times derivative. I hope you are doing. 1 time derivative minus minus plus, I think 2 gets cancelled, b k a square, and one more time derivative b a square. I hope now you got the answer. M star equal to h cross square by how much? B a square. Don't copy. Over. Next problem. Please don't copy. Next problem. December 2012. In a band structure calculation, comma, the dispersion relation for electron is found to be E equal to beta cos kxa plus cos kya plus cos kza, where beta is a constant and a is a lattice constant. No need to write, full stop. The effective mass, repeating the questions, the effective mass at the boundary of first Brillouin zone, the effective mass at the boundary of first Brillouin zone. What is the boundary of first Brillouin zone? Wait, kx, ky, kz equal to pi by a, of course, plus or minus. Okay, right. Options. Oh, that is not given in the question, just I said. A, 2h cross square by 5 beta a square. 5 marks, Babu, do it. If you know the differentiation, you are able to do it. H cross square by 2 beta a square. H cross square by 3 beta a square. Aram se. So energy is given. First we have to find a one-time derivative, dE by dkx, dE by dkx, dE by dky, dE by dkz you have to find. After that you can add, no issue. dE by dkx, how much? Beta minus sin kxa into a. One more time, similarly we can write d square e by dx square, tension adu. Again minus a beta, a square beta cos kxa. Please check, is it okay? Now I am finding d square e by dx square, where kx is equal to pi by a, or minus or plus or minus pi by a. I don't know how many of you are observing. So kx is pi by a gets cancelled, cos pi minus, that's why finally plus a square beta. Same answer you will get for y and z. So finally you can write d square e by dk square, finally d, not dx square, dkx square, pi by a, pi by a, pi by a. You will get the same answer for y and z also. That's why 3a square beta. Now find m star. H cross square by d square e by dk square. Please don't copy. If you are copying this, you don't know differentiations. So what is the answer, Amma? Answer. Don't do like this because it takes so much time. Because the same terms, do it for one and write similarly. You can save so much time. Next one. Question number 5. Ready? Yeah. The dispersion relation, the dispersion relation, the dispersion relation of electron in FCC crystal, of electron in FCC crystal is given by, please write down, don't get attention, very easy. How you treat the problem, the problem also treat you in the same way. How you are seeing the things in the same way you will get in return. Please see, easy. Kz by A, sorry, Kz A by 2 into cos Kx. Cos Ky by 2 cos Kz A by 2 plus cos Kx A by 2 into cos Kz A by 2. Full stop. The x component of velocity, oh, he is not asking total velocity. What is asking? X component. The x component of velocity at particular point pi by a 0 0, pi by a 0 0. Hello, he is not asking m star. Velocity equal to 1 by h cross dE by dk. Which component? X component. That's why you have to differentiate only with respect to kx, ky, kz, keep it as it is. Only kx term differentiate. After that, substitute. Kx is pi by a, ky is 0, kz is 0. First differentiate it. What is the second term? Second term will be 0. Why? There is no kx. So minus 4 epsilon naught by h cross. So I am differentiating with respect to kx. Minus sin kx by a cos ky a by 2, sorry, kx a by 2 plus second term is completely 0. Everywhere you are getting a by 2 out, I think. Am I right? Yeah, that we will write it outside. And the third term again minus sin kx a by 2 cos kz as it is, don't copy, into a by 2. Now I request you substitute the point pi by a for kx, 0 for ky, 0 for kz, minus 4 epsilon naught a by 2 h cross. Now pi by a substitute here, how much? Minus 1 na plus 1 na? Minus 1, because the sin kx by ax a by 2. So kx is a pi by a gets a cancel. Huh? Outside is there. Minus already here is 1 minus na. In the question there is 1 minus na. What is the answer? 4 epsilon naught a by minus 1. And this is a 1, because if you take this 0 and substitute 1, and here also you will get a minus 1, and this is equal to 1. So finally I think 4 epsilon naught a by h cross. Next problem. December 2015. The dispersion relation, the dispersion relation of electron in a 3D lattice, in a tight binding approximation, is given by Ek equal to alpha cos kxa plus beta cos kya plus gamma cos kza. The effective mass tensor at the corner of first Brillouin zone, at the corner of first Brillouin zone, pi by a, pi by a, pi by a has given the point. First corner of first Brillouin zone, pi by a, pi by a, pi by a. Ready? So here he is asking m star. Amma listen. What is m star? H cross square by d square e by dk square. But he is asking a tensor. Tensor means no need to get tension. M star xx, m star xy, m star xz. Similarly, m star yx, m star yy, m star yz. This is m star zx, m star zy, m star zz. Let us find one by one. Once you find the diagonals, you will get the same answer for all the terms. Next, once you find m star xy, no need to find this. M star yz, no need to find another one. Understand? I will explain one. M star xx is nothing but h cross square by d square e by dk x square. Differentiate partial derivative only. Although we are writing a d, you can write a dou. So, dou square e by dou x, dou k x square. Differentiate only with respect to kx. So, kx means what you are having only this term. Say yes or no. So, this is a h cross square and 2 times derivative. 2 times derivative. Alpha square. Alpha a square cos sin cos. But there is a minus. Is it clear? Now, at which point? Pi by a. Kx only there, that's why pi by a. Can you do it? After that, similarly, you will get same answer. No need to do. The reason, similar answer ante beta. D square e by dk y square. Let us do this. Kx is a pi by a, minus gets cancelled. H cross square by, come on say. Similarly, m star zz equal to, next second part. We would like to find m star xy, which is nothing but h cross square by d square e by dkx dky. Do you can write, no issue. Ready? So you have to first find this. No need to get tension. First do any one thing. That means de by dkx. First do the differentiation with respect. Anything you can do. It's not a problem. Okay. Happy? Ky. Cheppandi. A. Once again after that, you are doing the differentiation with respect to x. Answer. Over. All are zeros, only diagonal. Which one? Huh? Answer is given as h cross square by a square into 1 by alpha 0 0 0 1 by beta 0 0 0 0 given. What is this 0 0 0? Infinity. But here the options they have given 0 only. Why they have given? That diagonal is given properly, or maybe they have written infinity, maybe I copied it as 0, I don't know, I have to check it actually. But what is infinity? Infinity does not exist now. Huh? That's what I am saying. Or undefined. It cannot be infinite, that is sure. But options contains zeros. You are saying that is a 0. You are getting a. Why it happened like that? No. I think only principal effective masses exist and other things does not exist, I think. That's why they have given does not exist, that's why they have given 0 0 zeros, I think. Not exist. Yeah, only principal effective masses. Although it is a tensor, cross terms won't exist. Maybe in that point of view they have written zeros, I don't know. But in the question they have given zeros only, option. You can say does not exist. That component does not exist. Infinity is meaningless, does not exist. But you have to write in the tensor form, that's why they have taken as zeros, I think.